Monopoly Money, the State as a Price Setter by Pavlina Tcherneva. Case 4. All cases so far have assumed that GD equals HNFA equals 0. Case 4 introduces different levels of HNFA to Case 2A. Supplementary assumptions. Number 1. T equals $10. 2. Q sub LM equals 10. 3. The government sets the price of labor. 4. The government purchases firefighters only. This case graphs 3 conditions. Number 1. HNFA equals $0. Number 2. HNFA equals $2. Number 3. HNFA equals negative $2, where HNFA equals negative $2 means that the private sector dissaves as it borrows from the government. Here is the data for the 3 cases and the graphs that describe the number of firefighters that will work for the government at different wage levels. Case 4A. HNFA equals GD equals $0. G equals 10 plus 0 equals $10. PL equals G divided by QL equals 10 divided by QL. Case 4B. HNFA equals GD equals $2. G equals 10 plus 2 equals $12. PL equals 12 divided by QL. Case 4C. HNFA equals GD equals negative $2. G equals $8. PL equals 8 divided by QL. All 3 curves in Figure 7 are downward sloping. The more the government pays, the less it receives from the private sector at a given tax level. The 3 situations are characterized by different minimum wages that the government can offer, with full capacity confined to 10 people. In the first situation, curve P sub L equals 10 divided by Q sub L. The government is not running a deficit. HNFA equals 0. Hence, $1 is the minimum that the government can pay for a firefighter. At that point, point A, it will attract 100% of the capacity and everyone will be working in the public sector, fighting fires. In the second situation, curve P sub L equals 12 divided by Q sub L, when the private sector net saves $2. The minimum wage is given by a point B, $1.20. Similarly, for the third curve, that wage is $0.80. Changing HNFA does not change the basic relationship. It only shifts the curve. This shift can be expressed mathematically in general terms, as opposed to using particular values for our variables. Proof. Let G equals P sub L times Q sub L equal T plus HNFA. P sub L equals T plus P sub L equals T plus HNFA divided by Q sub L. Once again, P sub L equals the sum of T and HNFA divided by Q sub L, which equals T divided by Q sub L plus HNFA divided by Q sub L. Let net savings increase from HNFA to HNFA star by a change of HNFA equals by a change of delta HNFA equals HNFA star minus HNFA. G star equals P sub L star times Q sub L plus equals T plus HNFA star. P sub L star equals the sum of T plus HNFA star divided by Q sub L equals T divided by Q sub L plus HNFA star divided by Q sub L. P sub L star equals T divided by Q sub L plus the sum of HNFA plus the change plus the delta HNFA divided by Q sub L equals T divided by Q sub L plus HNFA divided by Q sub L plus the delta HNFA divided by Q sub L. P sub L star equals P sub L plus delta HNFA divided by Q sub L. Therefore, the curve has shifted by delta HNFA divided by Q sub L. We have found a general expression for the shift of the curve.